Alright, now we'll take some specific cases of distribution in combination. That is, in the whole process of selection, we'll take some specific cases. First we'll take identical objects, right? Because I have already told you maybe multiple times by now, I have memorized this by now, that when we have identical objects, similar objects, we don't use formula, right? Say for example, you have 6 identical objects. Okay. Remember, no arrangement involved, we are doing combination selection. So my question to you is, in how many ways can you select one? Most people will come up with the answer 6 even or 6 or some convolution of this. But now when you look at it, just think of it. You select this A, or you select this A, or you select this A. Is there any difference in your selection? After selection, can you actually say what I have selected this time is very different from what I did last time, right? So which means if the objects are identical, all the selections look same. Visibly we cannot differentiate, and if visibly we cannot differentiate, we can never take it as a separate case. Which means, in how many ways can I select one object out of 6 identical objects? Yeah, yes, I know the answer is coming up inside you. Yes, that is the right answer. There is only one. Whichever object you select is the same object. It's the same case. You cannot select and say, okay, this time it is different from what I did last time. It's all the same only, right? So in how many ways can I select one object? One way. In how many ways can I select 2 objects? This is a lot of fun when I do it in the class, because straight away people come up with 2. You know, we have been hammered into thinking in a sequential fashion. Our schools and colleges have ensured that always 2 will come after 1. And whatever be the case, we come up with this answer 2. But let's use the other part of our brain, which has been dormant for ages now, the logical part. In how many ways can I select 2 objects out of 6? If I select these 2A, or the last 2A, or the middle 2A, or the first and last A, or the second and fourth A, can you take the 2A and say these 2A are definitely different from what I did last time? Is it possible? No. All 2A's are same. So whichever 2A you select, it will be same as what you did the previous time. So in how many ways can you select 2 objects out of 6 identical objects? Yes, now it's like a tornado inside you. You know, it's bubbling to come out. Yes, the answer is 1. Enlightenment, revelation. Which means 3 objects, 1 way. 4 objects, 1 way. 5 objects, 1 way. Thankfully I took only 6 as my example. 6 objects, 1 way. And 0 objects. You being a very finicky guy, you have decided to reject all of them, I don't need them. 1 way. Okay. Then the question comes, the elaborate question, the well-written question. Say for example, you come to a party and there is a tray of sweets offered to you. Right? The tray has 6 identical sweets. And the purser, or say the guest, the host who comes here, is very insistent that you take up 1 sweet. If you have been to one of these Indian ceremonies, you will understand what I am trying to say here. And the best part about this interaction will be that none of you have ever seen each other before and are unlikely to see each other any time in the future. But that exchange of sweet, where he insists that you take the sweet from the tray offered by him, I mean, that is what Indian symbolism is all about, right? So there is a tray with 6 identical sweets. So decision is yours. Some of us are very particular about how we behave in ceremonies, so we say no thank you, right? Then some of us want to be a little courteous, so we say okay, I'll take 1. Then some of us say let's take 2, maybe I'll like it, I'll try, or if I'll offer to someone else, yeah, 2. Some of us are a little more adventurous, so we go for 3, 4, 5, and I don't even want to talk about people who actually go for all the 6 sweets. But there are people like this, we have met them, which means we can take any of these decisions. But in how many ways can a person make such a decision if a tray with 6 identical sweets is offered to him? The answer will be 7. There are 7 ways of taking a decision. Each decision can be taken in 1 way, but we don't even know how many sweets you are supposed to select. So what kind of question are we talking about here? N identical objects, R is not defined. R can take any value from 0 to N, which means in how many ways can I take that decision? N plus 1, right? I've just used a little bit of nomenclatures here, but I'm sure you understand this. N identical objects, all same, sweets are all same, especially once they go inside you. R is not defined. How many do you select? Not defined. So R can take any value from 0 to n. In how many ways can you make a decision? N plus 1 is my answer. Alright, this is only for identical objects, remember that. Okay, alright. So n plus 1 ways of making that decision. If I take an extension of this, say 5 dairy milk, 4 Kit Kat, 6 Bonville, 3, I'm running out of chocolates and confectionery here, Perks, right? My cameraman has helped me with this. Right, okay. Now in how many ways can you take a decision? If a tray, this is not a tray, this is a booty. This is your golden chance, this is your good luck day. So if a tray like this comes in front of you, right, depending on your, personality, disposition, the number of decisions open to you is for 5 dairy milk, 6, for 4 Kit Kat, 5, for 6 Bonville, 7, for 3 per 4. So these are the number of ways in which you can take a decision. The total number of decision options open to you, right? Where the decision has not been defined, whether you will take 1 of this, 2 of that, 4 of that, that has not been decided. So before that, in how many ways can you take a decision? This is the answer. Which will come to what? 28 into 6 is 168 into 5. 168, 840. So it comes to 840 ways. Now suppose you decide that okay, these are the various ways of taking a decision, but one thing is for sure, I'm going to take at least one sweet, right? One of it. I'm not going to reject it all, right? Which means out of 80 possible ways of selection, the only thing you are not comfortable with is when you say no to dairy milk, no to Kit Kat, no to Bonville, no to Pearl. Everything else is acceptable to you, but you don't want to be in a situation where you say no to everything. Which means in how many ways can you take a decision where you select at least one? 830. Right? Some of you, I'm sure, were thinking the answer would be 5 into 4 into 6 into 3. Right? No. Maybe that is the answer of the next question. Let's see what the next question is. In how many ways can you select one of each type? I'm not going to say no to any chocolate. I may take 1, 2, 4, 5, whatever, but I'll take at least one of each chocolate. Which means, in how many ways can I select my dairy milk? 1 or 2 or 3 or 4 or 5, not 0. And in how many ways can I select one dairy milk? We have already seen that it's one way. 2 dairy milk, one way, and so on. So in how many ways can I make a decision regarding dairy milk where I don't have an option of rejecting it? 5 ways. 1 or 2 or 3 or 4 or 5. Same holds true for 4 Kit Kat, 6 Bonville and 3 Perks. So in how many ways can I take my decision where I'm not going to say no to any chocolate, but how many I take depends. The answer will be 5 into 4 into 6 into 3, which is 24, 72, 360. Okay. So in how many ways can I make my decision? In how many ways can I make my decision where I take at least one? In how many ways can I make my decision where I take at least one of each type? And this would be my answer. Alright, I hope you understand this. Now let's take a different case. Say there are 10 chocolates, right? 10 eclairs, chocolates, whatever, and you have been assigned the task of distributing these 10 chocolates between 2 kids, A and B. Alright, you being the elder brother and all, you have been given this task by the busybody moms of these two, prompt kids, that you have to distribute chocolates. Not a task you enjoy or relish, but you have to do it. So in how many ways can you go about doing it, right? Now, just imagine what is happening to us right now. I'm sure some of you are actually thinking of NPR and NCR. We have come to such a stage in our life when even when we have to give 10 chocolates to 2 kids, we have to rely on academic information. This is a very sad stage of my life. But anyway, let's come back to what I was supposed to do. Let's give 10 chocolates to 2 hungry kids. In how many ways can I do that? Maybe I can give 10 to him, 0 to him. Then I feel some pity for him, so maybe I'll give 9 and 1. To make matters a little more balanced, maybe 8 2. Sense of generosity, 7 3, and so on. And maybe I can reach a stage where I give 0 to this kid because somewhere I realized I don't like him at all. And 10 to all of this. 10 all, 10 to this second kid. Right? All of this is possible. So how many different cases can be there? 11 cases. Right? This is based on the fact that the 10 chocolates which are assigned to me are all identical chocolates, all eclairs and all, right? So in how many ways can I give 10 chocolates to 2 kids? 11 ways, right? It's very easy to understand. This is similar to what we did here. when a man comes with a tray and offers it to you, right, you realize what you pick and what you don't will add up to the total number of chocolates, which is similar to the case that we are doing here. Giving it to two kids is basically saying, this is what I pick, this is what I reject. So what I pick, what I select and what I reject will add up to the total. But the matters become a little more complicated when I have to divide it into three groups. What if there are three kids? Two are any which way is difficult to handle, three kids and nightmare. So if I have to give 10 chocolates to 3 kids, I can make an equation like this. Why? Because that is what I have been doing all my life. So I'll make an equation like this. 10 chocolates to be distributed amongst 3 kids. Now when I look at an equation like this and try to do it by trial and error, like I did in the previous case, I realize I'll end up with more cases than my tiny brain can fathom. So what do I do then? I seek help, and help comes in handy. There is a formula to solve this. We'll explain how the formula works, right? We always promise we'll do that, right? So maybe this time we'll actually do it. But first, I'll tell you what the formula is. The formula goes like this: n plus r minus 1, cr minus 1. This is the formula. Where n is identical objects, the one which we are supposed to distribute. R distinct groups, the truant kids, nothing to do, hunting, middle-aged men like me, right? And the formula is n plus r minus 1, cr minus 1. Okay, there is only one problem, or you can say condition of this formula. The formula works when the decision maker, me or you, have the power, have the right, have the entitlement to give 0 chocolates to any kid. Which means no one can stop me from giving 0 chocolates to this kid, right? So if I want, I can give 0 to A, or if I want, I can give 0 to C. Obviously I can't give 0 to all 3, because my primary objective is to ensure that 10 is distributed amongst these 3. So 10 has to go to them. But I have the power, I have the capability that I can decide that if A gets 0, he gets 0. He has to get 0. All 10, give it to B and C. Or B and C both get 0, give all 10 to A. All these cases must be acceptable. Only then I can use the formula, because formula does not understand conditions or constraints. Right? We understand this? Okay. So, 3 kids, 10 chocolates, all my power I can give it to any one of them. But what if there is a constraint, a small twist in the story? Not a small twist, a big twist. Say there is a huge mother there is a mom, A has a mom like most of us do, and the mom insists that my kid must receive at least 2 chocolates. You can't help it. I mean, in these things I can't even explain how difficult it becomes. You have to give 2 chocolates to A. So A plus B plus C is equal to 10. Just when you thought you have reached the end of the tunnel, there is a formula to deliver you here, you realize there is an additional problem. A has to get 2 chocolates. Your formula does not empathize with you. What do you do now? You use your common sense. Give 2 chocolates to A. He wants at least 2, give it to A. Now if you give 2 chocolates to A, you still have 3 kids with different parents. That sounds so weird. But you only have 8 chocolates now. So out of 10, 2 chocolates gone. 8 chocolates, 3 kids. And now A's mom is okay with the fact if I don't give any more chocolates to A, because he has got his minimum quota of 2. Right? We understand this? Now I can use the formula. So how do I use the formula now? N is 8. R is 3 distinct groups. 3 minus 1. N plus R minus 1. Then this huge C or combination. Then R minus 1. Which means 3 minus 1. 3 minus 1. So my answer will be 11 minus 1, 10, C2, which is actually 45. And therefore this is my answer. Right? So it's very simple. Once you understand, obviously it's very simple. No credit to me, of course. Right? But the way it goes is, identical objects, distinct groups, there is a ready formula to use it. The only condition is minimum value of each group must be 0. Minimum value is each group is 0. I am emphasizing on this again and again because I faced this in the class. What if all the groups are 0? I mean, how can all the groups be 0 when you have to give 10 to them? So it is impossible. But they can be 0. There cannot be anything in the question which suggests that they cannot be 0. That is what the question is trying to say. Right? So the minimum value of each group is 0. That has to be there. In case that is not there, then how to override that problem? Whatever is their minimum value, give it to them. reduce your total by those minimum values and then apply the formula and you will still have the answer. Let's take a very simple case. Say A plus B plus C plus D is equal to 100. Where A, B, C, D are all natural numbers. Minimum value of A is 2, B is 3, C is 4, D is 5. Right? What do you do in this case? You give their minimum values to them. So you give 2 to A, 3 to B, 4 to C, 5 to D. So after giving this, out of 100 which you had at your disposal, you've already done away with 14. So now you will have only 86, which is to be distributed amongst these 4. And then you use the formula straight away because you have given them their minimum. So now you can afford to give them 0. They also don't mind now. They got what they wanted. Now they are at your mercy. And you use that discretion now. So 86 plus R is 4. Remember that. Don't get confused between N and R. N is the right hand side, the identical object, 86 chocolates. R is the number of kids. And trust me, though they look alike, all kids are different. So 86 plus 4 minus 1. C 4 minus 1. So your answer will be 89C3. And definitely I'm not going to take the trouble of actually finding this value. But I leave it to you. Make sure you find this. Alright, okay. So we are done with this now. We have completed this allocation, identical objects, distinct objects, different groups, 2 groups and all that we have done. Now we will come to distinct objects and distinct groups. What happens in that case? Alright.